Hi folks, we're going to take a look at this identity here that they're asking us to prove. So clearly going to start with the left hand side, offers me a lot more opportunity to do some manipulation. So left hand side is equal to, so now here, not much to do with sine x, so sine 3x. The question is what can I do with sine of 3x? Well, I can write it, okay, because again, I'm trying to relate this to some of my other identities. So the only thing I could think of here is to relate this to an addition and write this as sine 2x plus x. And then I can use my addition formula for sine. And looks like really it's the only thing I can think of for the denominator too is write cos 3x as cos 2x plus x. Okay, so let's continue on here. Let's apply those formulas. So sine x minus, okay, and so here it's sine of the first times cos of the second plus cos of the first times sine of the second. Okay, so there's just our addition formula. You can look that up on your formula sheet if you need to. Divided by, so cos x plus, so here it'll be cos of the first times cos of the second minus, remember cosine always the opposite sign, of sine of the first times sine of the second. Okay, so now we have to figure out what to do here. Well, I know sine 2x in both of these. There's no question that I'm just going to have to use 2 sine x cos x, the double angle formula for sine. For cosine, it's not quite as obvious which one I'm going to use. So I'm actually going to hold off on cos 2x. So sometimes not a bad idea to do that and see if something inspires me a little bit here. So here I've got sine x, and then here minus, so this is just going to be 2 sine x cos x, my sine double angle formula, times another cos x, so that's going to be cos squared x. Okay, and then don't forget minus, like I said, I'll leave cos 2x on its own. Okay, and I'm going to do the same thing in the denominator. I think is I'll leave the cos 2x as is for now because it's not obvious what I'm going to use. So minus 2 sine x cos x. Okay. And here there's another sine x that I'm multiplying, so that'll be sine squared x. All right, so let's see what we're left with here. So the only thing I can see right off the bat, so I see a lot of similarities between numerator and denominator, so I'm sort of hoping eventually some nice stuff's going to start happening. But I do notice that the numerator's expressions all have a sine x. So I think I'm going to factor out a sine x. So let's see what we're left with. We're left with 1 minus 2 sine x cos squared x. Oops, sorry. I took out that sine x, so just 2 cos squared x. Okay, minus cos 2x. Again, factored out that sine x. Sorry about that. Okay, here in the denominator, I see there's a cos x in each of the three. So cos x is equal to, so what am I left with? 1 plus cos 2x. I factored out that cos x, and then minus 2 sine squared x, and that cos x was factored out. Okay, so something very interesting here, because what do I notice as my factors in front of those two brackets is a sine x over cos x. And this is where I'm going to take a look at that other side of the equation, and I have negative tan x. So of course this is equal to tan x. So somehow it looks like we're going to need to show that this whole remaining part of the fraction is going to be equal to negative 1. Okay, so this is where now we're going to have to try to come up with a strategy for these cos 2x's. Okay, so let's just remind ourselves what my possibilities are. Okay, so my first instinct here would probably be to change this to 2 cos squared x minus 1, this one here. But I notice that if I change that to a 2 cos squared x minus 1, I'm going to have a negative 2 cos squared minus another 2 cos squared. So that doesn't get eliminated. And here I'm going to be subtracting a negative 1, which means that this 1 is also going to stick around. And something very similar is going to happen in the denominator. If I replace this, my first instinct is to replace it with 1 minus 2 sine squared x. But if I do that, again, the 1 is going to stick around and the sine squareds are going to stick around. So while that might have been my first instinct, I don't think that that's where I'm actually going to go, because I'm worried that I'm just going to end up with a lot of terms that aren't going to cancel out with each other. So instead, let's try something else. 1 minus 2 cos squared x, and let's change this to minus, and we'll use the other one, 1 minus 2 sine squared x. Okay, denominator cos x, and here 1 plus, I'm going to change this instead to the other one, so 2 cos squared x minus 1. Okay, then minus 2 sine squared x. All right, so one nice thing that does happen is the 1's cancel out. Trick we've seen before. Same thing happens in the denominator. The 1's cancel each other out. So the question is, can we work the other stuff? Can we work some magic here? Well, let's see what we're left with. So we have sine x. Okay, put it in brackets because I think I'm going to be doing some factoring here. And I notice that I've got a negative 2 that I could factor out. Here this becomes a positive 2. So let's see what happens when I factor out, either a 2 or negative 2. So let's factor out a 2 here. I'm going to factor out a 2, and what are we left with? Well, we're left with negative cos squared x, and this is going to be plus sine squared x. Okay, remember we factored out the 2 there. And in the denominator, let's see what happens there. So we've got a cos x, and again, there's a factor of 2. Okay, so take that out. And here, what are we left with? We're left with cos squared x minus sine squared x. Well, the 2's cancel out, that's good. But these are not exactly the same, but they just differ by a factor of negative 1. And in fact, remember what we needed on the other side of the equation? We needed a negative. So I could have probably done this in the last line too. Okay, but let's factor out a negative 1 from the numerator. And what are we left with? We're left with positive cos squared x minus sine squared x, because I factored out a negative 1. Here, we'll leave the denominator as is. And lo and behold, those things cancel out. And what am I left with? Negative sine x over cos x, which is just negative tan x, which is equal to my right-hand side. And so I've proven the identity. Okay, so this one, definitely a bit of a tougher one. So step number 1 was to realize that this 3x could be split up into 2x plus x, which then allowed me to use my addition rules. Okay, step number 2 was to make the obvious change, which was to turn sine 2x into 2 sine x cos x. And notice how I waited on the cos 2x to try to see what might work out nicer instead of just going ahead and changing, picking one of the 3 and possibly not picking the right ones. So it's very possible that even choosing some other versions of cos 2x would have worked out also. Okay, so this we do see eventually did work out. All right, that's it for this one.